Thank you, my chair lady. Thank you, Evie, for this invitation. By the way, what I'm going to say is very complementary to the previous two speakers. So this is a uh, very lucky outcome from your invitation. I'm going to speak about the oxyredox regulation. At the end of my talk, I hope you will understand the meaning of these two symbols. But let's go. This is our learning objective today. This could be a PCOS lady, but it could be an obese man with type 2 diabetes. Doesn't change. I suppose you know the answer. I suppose I'm not going to modify your answer. I'm going to give you better understanding why you are answering that. So we speak of physiology. So please shut down your mind, clear your mind, forget all of those stories of antioxidants. Magic bullets, resveratrol, melatonin, that are for believers and for those selling tablets. In the physiology, we should not speak mainly about oxidative stress. We have to speak of oxyredox balance. This is what we have into the biochemistry. And oxyredox balance is a stupid simple story. You have a cellular source of reducing equivalents, SH groups. And they circulate with a tripeptide, that is glutathione. It is the redox buffer of the cell, and it will be feeding the whole antioxidant system. All that we need is to have metabolisms reducing equivalents. Just to give you an idea and to comment on the discussions of today, whatever antioxidant molecule you use, you will put in something here or here or here into the cascade. Whatever is downstream will undergo reductive stress, as well pathologic, and the rest will remain under oxidative stress. Does not work in that way. Forget it. If you like antioxidant, do it, but moderate, they can be a poison. Now, where is reducing power coming from? In this planet, we have two main metabolic pathways. That is the carbon cycle, to add carbon units to the molecule, and the transsulfurations, that is to manage oxygen consumption. This is the basis of life for every living organism in this planet. And we know, this is on the textbook of biochemistry, not my research. How is it regulated? This is the carbon cycle, where the methyl group S-adenosine methionine is created to add to any molecule, including DNA methylation. And this is the transsulfurations. And the end product of this cycle, S-adenosine methionine, upregulates glutathione synthesis. It is a fantastic homeostatic mechanism. This is the enzyme. It is called CBS, cis-adenine beta synthase. Basically, it is a heme group acting as the redox sensor. When the environment into the cell is oxidative, it gets from ferrous to ferric, and it gets activated. But to work, it needs this one to bind here. So this cycle is upregulating the other one. First question, if this cycle is working, this will be working. Another concept, speaking of oxyredox balance, I don't want you to be biochemists, but this is really the basic and very simple stuff. Please, I don't go forward if you do not understand this. Glutathione is regenerating the oxyredox coenzymes, NAD, simple or phosphate. It donates the reducing equivalents. And this is the coenzyme for any oxyredox reaction. Oxyredox reactions can go either way, back and forth, according to the availability of the reduced equivalents. So this is regulating everything in your metabolism. When you speak of oxyredox imbalance, forget all those strange things of DNA damage, 8-oxoguanosine, whatever. Leave it to the biochemist. For us, it is metabolism. This is the problem. Now, back to our pathway, what is fantastic is that in the homeostasis is that, and this is a new understanding, is that in this cycle, do you remember, it is the one that is activating glutathione synthesis. On the other side, glutathione is activating the cycle because the main enzymes here are oxyreductases. So when glutathione is high, this cycle will be high as well. This is the cross feedback. There are two pathways that are upregulating each other. And this is the final outcome. You have the carbon cycle, the GSH release. They activate each other. They together constitute antioxidant defenses, DNA methylation and epigenetics, and the energy production, which is the real topic I'm going to. But before doing that, I have to show you what is then what we call oxidative stress. It is a vicious loop. It is a vicious loop because independently of what is the triggering cause, feeding, pollutants, genetics, whatever, you have a problem either here or here. When you start having a problem, you have a vicious circle, because if you have this one is not working, you don't have the activator. If the activator is not activating, you not have the upregulation of the oxyreductases, and so on. It is a vicious circle. And this molecule that is in the middle, homocysteine, will start growing. That's why homocysteine is a very precise indicator that something is going wrong in your oxyredox balance. It is exactly the link between the carbon cycle, methylations, and antioxidant power into the cell. Homocysteine going up, and you see what is the problem here. Now, this is an extra slide I had this morning just because I am with the endocrinologists. Please, if you understand this concept, this is steroidogenesis. It is entirely made of oxyredox reactions. What is happening in your steroidogenesis is entirely depending on the balance of this. So there is an extremely direct link with the steroid endocrinology and oxidative stress. The model is really complex. Maybe next year, Evie, for an invitation, I will be able to tell you exactly what is happening here. But this is the main point for you endocrinologists. Now, let's go to the energy. And this is our point now. Actually, independently of whatever lifestyle, your main, by distance, source of oxidative load are mitochondria, is your energetic metabolism. Because into the mitochondria, I invite you to look at this paper that is really the one that makes you understanding how does it work. And this is taken from this paper. And you see here the major sites of ROS release within the mitochondria. Just to give you an idea, this is CoQ10. CoQ10 is a poison. If you give, I will show you why. If you give CoQ10 to somebody in stress, let me show you why very soon. Because the oxygen that we work, this is the pathway. It is a typical phantom reaction. That means that into the respiratory chain, here we have energy, substrates burned out. We produce NADH that stores the energy. NADH goes here into the respiratory chain, and the energy of the reducing equivalents is exchanged with ATP production, okay? Very simple story. Now, this oxygen reduction is a non-efficient step. It is a two-step reaction. O2 accepts one hydrogen from NAD, and you get the hydroxyl radical. Thereafter, the hydroxyl radical is further reduced to water. This process is not complete. It is called leakage of hydroxyls. And the leakage of hydroxyls in standard conditions is around 3% of the oxygen is going to hydroxyl radical. When the pace of energy production increases, that is, we were speaking just a while ago of physical activity. Moderate is good. Intensive, you will have a strong rise of your production of free radicals from the mitochondria. In whatever reason the energy demand increases, you have more of O2 worked, consumed, and a higher rate of it is going as hydroxyl, and the rate of your oxidative production from the mitochondria grows exponentially. This is the point. But, of course, there are compensative mechanisms. Which are these mechanisms? One of them is obvious. scavenging of free radical. This is again glutathione. It is glutathione peroxidase, the basic reaction of glutathione. It will be scavenging hydroxyl anions. The second one, it is more delicate. It is a reversible inhibition of the sessions of the respiratory chain, which is made by several processes, but the main one is glutathionylation. That is, GSH binds on the sessions and blocks them very reversible, so that it is a dynamic equilibrium. The mitochondria will be trying to produce as much energy as possible without going over to the limit, to the threshold. And the third mechanism is insulin resistance. That means that the mitochondria are signaling to the membrane, do not let other energetic substrate to enter. I cannot process. Clear? How does it work? Because hydroxyl radicals are dismutated by manganese salt, SOD, into the mitochondria. This is now diffusible. This can permeate membrane, goes on the cell membrane, inactivates the insulin receptor, and downregulates the energy production into the mitochondria. Just to go a little into the details, not much, this is one of the possible explanation of the insulin receptor. You know that it has several substrates. The best known is insulin receptor substrate 1. There is a phosphatidylinosyl kinase here that is the regulated one. And basically what is happening is that this kinase has a kinase activator, the activator of the epimerase, which needs NADPH to work. And of course, there is a double redox regulation here, because this is redox activated. And this is depending on the availability of GSH. And this is, again, you see, the reconstruction. If you are under, if your mitochondria are working out of pace, you are requesting them too much of energy, you have this blockade I showed you. Then you have also this blockade, because it is also redox activated, and you have insulin resistance. No exposure of GLUT4, no entrance of glucose, and glucose and free fatty acid funneled into glycogen synthesis and lipogenesis. This is the homeostasis. All of this is very well shown from an experimental point of view. This is a milestone paper that you can find in the literature. It is open access. This is an invitation. And they clearly showed that the superoxide activity into the mitochondria comes before insulin resistance. It is the triggering one. It can be reversed if you put antioxidant power into the mitochondria. And it is enough alone to drive insulin resistance. And it regulates the insulin action in vivo. So this is not a lab story. This is what is happening in the physiology. Now, from mitochondria, we are speaking of aging. From mitochondrial dysfunction to aging, of course, a lot better than whatever I can do. We got explanations of what are ages here today, and all of the problem of whether we can get rid of that or not. What is the regulation of that? Of course, this is one side of the story. The second side of the story is epigenetic instability. That means both mitochondrial and nuclear DNA dysregulation. Here, I may have some further to add. It is not really, the main problem in mitochondrial instability is not lack of DNA methylation. There are animal models showing that even if there is only one active methyl group available, it goes on DNA. It is a top priority. The main problem is oxidation of the methyl marks, which will nullify the regulation. So and it is a problem also with the studies with the metaboloma, because you see it methylated, but actually it is dysregulated, because either the oxidation of the methylcytosine or of the guanosine will revert the domain from hydrophobic to hydrophilic, and you have the transcription factors attaching. But this is another lecture for another time. And of course, at the end, you have the multiple organ failure. And now, from insulin resistance to diseases, This is a simple and stupid concept, but we have to fix it. You have mitochondrial dysfunction. Then, of course, if mitochondrial dysfunction is affecting the big amount of the muscles, you will see insulin resistance. You will see high glucose, so there is a deficit of glucose uptake and the rise of insulin, and you see all of it. If this is happening into the ovarian follicle, very likely you will not see any insulin into the blood. It is the follicle. You will find here, you will find homocysteine circulating. Here you will find homocysteine into the follicular fluid, but it is there. And this also explains a lot of discrepancies with homocysteine level, their predictivity. Does PCOS has insulin resistance? Yes, it does, always. But of course, it is compensated. You cannot see it into the bloodstream, unless it is a PCOS with a pre-diabetic state, and then it goes faster and in a different way. And we also start understanding some of the phenotypes of PCOS that we see. Now, just to recall you a study that I'm sure most of you are very familiar with, the ACCORD study. I know that there have been a lot of publication after this, a lot of possible explanation, a lot of possible counter-explanations. As a matter of fact, it is there. And it is there to tell us that if we increase the aggressiveness of our treatment in lowering blood glucose and putting down glycated hemoglobin, people start dying more. This is the story. Simple. No way. And it is time to deal with this seriously. When we're using insulin agonists, whatever, this is what we are doing. Do you remember? We had the mitochondria saying to the cell, please don't give me glucose. I don't want it. Otherwise, it will kill me. And this is exactly what is happening when we use insulin. We give it exactly to those that will not tolerate the glucose entrance, and we kill them. And by the way, just to go on the train of my previous speaker, this is another main explanation for the loss of beta cells, because the beta cells, they express the insulin receptor. And this is one of the explanations for the biphasic nature of insulin secretion, because the beta cells are regulated for their secretion exactly on the output of hydroxyl radicals. So when we give insulin, we kill beta cells because we force beta cells to uptake glucose. They will be producing more free radicals, and at the end of the story, they die. And this is one main contribution, both in the exhaustion of the beta cells in the natural disease, but also in the acceleration of the progression. When anytime you have a type 2 diabetes patients and you start giving them insulin, you are accepting the idea that the life of that patient will be shorter than what it was written on his biologic clock, because this will be accelerating everything. We must be very well aware of these mechanisms. And indeed, my researcher of the study, this was the conclusive sentence of the study. Yes, you can go for therapeutic interventions, but first, you should eliminate the primary defect. I understand insulin is a must for most of our patients, but we must be conscious what we are doing with that. The final summary, I hope I'm not going too long. So the final recipe is simple, simple, simple. Keep high your glutathione into the cell and into the mitochondria. This will lift up the threshold for energy production toxicity into the mitochondria, and this will give to the mitochondria the ability to process glucose. They will uptake it without any insulin. They remove insulin resistance and start working their substrate. So diet. Now we go back to the diet. What does it mean? Does it work? You remember the slide. Now all that we need is to understand what is here. Where the diet is doing that. Of course, I cannot modify in one day the diet of the people, but I can use supplements. I can formulate a supplement and have a tool to test. This was the first start I was being using. It was, as you see, there are no antioxidants here. Forget it. You need a methyl donor. You need cofactor for the activation of the methyl donor. You need B12 to pass the methyl group from folates to homocysteine. You need zinc, because zinc has no reservoirs. We depend on daily assumptions. And this enzyme, they work by zinc finger. They need the zinc to bind homocysteine and to present the substrate to the reaction. You need B6 because it is the essential substrate for CBS, I showed you. And we need cysteine, SH groups. I'm going to show you where we take it, usually, from the diet. This was a supplement that we tested. And this is not our topic today. This is male infertility and female infertility. It was working crazy. We were doubling the pregnancy rates. It was never happening with any type of support we have been using. The studies, open access, again, go and look at that. But we know it works. It works, but of course, we have to move a little farther, because what is the problem? If I am in this situation where there is this double blockade, even if I eat folates, they will not be activated. And this is a blockade, and then anything will be working here. So there is, once you are into the loop of oxidative stress, there is resistance of the system. You get being less able to use what, even if you are eating properly, then it is not enough anymore, because you are into this type of situation. In some ways, you have to unblock this. And also, there is another problem that has the enzyme variants. And now we go to the Mediterranean population, especially. There is a lot of talking about MTHFR, very famous, but roughly half of us in this room has the heterozygous defective variants, and 1 out of 4 is homozygous. These are the numbers. But all of these, they are all in double-digit prevalence, and typically each of us has associations of more than one defective variants. Actually, they are not defective variants. I have no time today. They are physiologic variations, because if you are weak here, you are stronger here, so you will be less able in growing, but more producing energy. Complex story, not for today, next time. But whatever oxidative blockade and whatever enzymatic variant will have no effect if your diet is including the activated vitamins, the activated substrates. That is the secret. If you are getting folates as reduced folates, as methylfolate, doesn't matter if you have the variant here or if you have the oxidative blockade of the enzyme, they will be working. More important, by distance, the most important everything is methylcobalamin. That is the critical substance, really. And if you are having in your diet methylcobalamin, it is ready to produce. Oxidative stress impairs your production of 3-methylglycine from choline. If you take betaine, you have it ready, and it will be working anyway. And the same is for the sulfurated proteins. Even if I have a blockade here, I can feed the pathway from downstream. And this is, I've been using now this type of supplementation. I already showed, not relevant. This is just to show you that we are speaking of very physiologic amounts. Forget the thousands micrograms of vitamin B12, crazy stuff. You don't need. This is your daily requirements, nothing more than that. How does it work? It works because once you have some cobalamin ready here, this one will start moving some homocysteine. Does not need anything else. It is ready. When some homocysteine moves, you start having some S-adenosine methionine, and this gets activated. And you get some glutathione. Thereafter, this one is ready, in spite of the blockade, will be further feeding the reaction here, and so on. And you remove the blockade. When you do this, then you start using all that you eat. It goes back to a standard situation. You just have to remove this impasse of the system. I've been using it already in a small case series, not yet studies. Homocysteine, needless to say, 100% of cases, they are cured immediately. It goes normal, everybody. No resistances so far. These are mine, but I also very few, but I have also other colleagues working, and zero resistances. In PCOS, they improve dramatically within 1 month. At 1 month, you see again the patient, and she's another patient. And diabetes, I am very careful because I've been treating very, very mild. Because you know, you never know. It's first experience. So I was treating males compensated with gram metformin and moving for a progressive withdrawal of metformin, and it works. I have the only one possible true resistant. I don't know why. The other one was a compliance issue. And what is more relevant is that these patients are telling me they don't care about glycated hemoglobin. They tell me, I feel better. They are a lot happy because they control their postprandial glycemia, and it is a lot lower than when they were using metformin. This is the way to go. There is a lot of limits. I'm a scientist. It is my duty to list you this. We are small numbers, no randomization. Mild cases could have improved just because of lifestyle changes. I don't know. And there is the selection bias. They are Italian patients. They are carrying all of these genes, and of course they are very sensitive to this mechanism. Whatever it is, but I can tell you it works. And what is this stuff? What are we speaking? Back to diet. Betaine is cereals. And cysteine is the wheat and eggs. Eggs contain everything. You can live only with eggs. B3, again, legumes, zinc, all the seafood, basically. B6, again, fish, poultry, organ meats, not very popular anymore, but also in some vegetables. Methylfolate, lettuce, green vegetables, tomatoes. They are very rich. In ready methylfolate. We know a lot less of methylcobalamin, no studies, but we expect it to be very abundant in oily fish, especially, the ready methylcobalamin. And all of this, as you see, it is Mediterranean diet. Nothing else than that. It is simply what we are not doing because I had my mother doing it for me. I don't have it anymore, and I cook by myself. So in the Mediterranean area, very final message, my time is gone. The traditional diet was very rich in these ready substrates, and this gave us a configuration of our genes profiled on that, because then that's why we have all of those defective genes, because then it is an advantage. I have no time today, but you develop less of cancer, for instance. The malaria plasmodium does not replicate because it is fully dependent. More relevant, there is a brilliant study in Italy showing that elite athletes had a very higher frequency of defective variants of all these enzymes because they produce more energy. It funnels homocysteine into glutathione secretion. But as soon as we change the diet pattern, we are in troubles. You see the epidemic of polycystic ovary that is around. And you also see, I mean, I have to stop. This was the learning objective. This was the obvious conclusion. You are already saying that. My message is focus on micronutrients. Diabetes has been, as of until today, a disease of macronutrient intake. No. It is mainly a disease of micronutrient intake. And when we prescribe diet to diabetes patients, very easily to restrict their intake, they will restrict their micronutrients intake. And you get the opposite effect. Thank you for your attention.
Thank you very much indeed. You gave us a whole spectrum of considering micronutrients, which we are not familiar. And in fact, we have many doubts about their utility since they have been advertised, but we don't really know mechanisms behind them. So thank you for giving us quite few mechanisms to start thinking about them seriously and based on biochemistry. Now,
metabolism.
since your first slide was about PCOS and the last one is about PCOS, and you had a study in which you gave this complement and showed improvement of ovulation, right? For how long you gave it, and can we give us something more about these patients? Because I guess it was an uncontrolled study, or so
no,
can
that is
we
not a
believe
study.
That? Can we believe that?
That is not a study. That is a personal experience, completely different story. And you know, when you do that, typically you suffer the loss of negative cases. They do not come back. So be careful. As a matter of, out of those PCOS patients I was showing you, there were 8 anovulatory. All of them ovulated in the first month. All of them. Now we have a controlled study ongoing in Italy. It will have the free testosterone index as the endpoint, but we have to do it. I started this only at the beginning of this year, so the amount of data, we know it works because we had the other studies on the male and female infertility, on the gametes, and we saw the mechanism is extremely powerful. Then now to define, the clinical story, it will take years.